Medieval warm period. Global average temperatures show that the medieval warm period was not a global phenomenon.
The medieval warm period, MWP, also known as the medieval climate optimum or the medieval climatic anomaly, was a time of warm climate in the North Atlantic region that lasted from c. 950 to c. 1250. Climate proxy records show peak warmth occurred at different times for different regions, which indicate that the MWP was not a globally uniform event. Some refer to the MWP as the medieval climatic anomaly to emphasize that climatic effects other than temperature were also important. The MWP was followed by a regionally cooler period in the North Atlantic and elsewhere, which is sometimes called the Little Ice Age, LIA. Possible causes of the MWP include increased solar activity, decreased volcanic activity, and changes in ocean circulation. Modeling evidence has shown that natural variability is insufficient on its own to explain the MWP and that an external forcing had to be one of the causes. Research. The MWP is generally thought to have occurred from c. 950, c. 1250, during the European Middle Ages. Some researchers divide the MWP into two phases, MWPI, which began around 450 AD and ended around 900 AD, and MWP2, which lasted from 1000 AD to 1300 AD. MWPI is called the early medieval warm period while MWP2 is called the conventional medieval warm period. In 1965, Hubert Lamb, one of the first paleoclimatologists, published research based on data from botany, historical document research, and meteorology, combined with records indicating prevailing temperature and rainfall in England around c. 1200 and around c. 1600. He proposed, evidence has been accumulating in many fields of investigation pointing to a notably warm climate in many parts of the world, that lasted a few centuries around c. 1000, c. 1200 AD, and was followed by a decline of temperature levels till between c. 1500 and c. 1700, the coldest phase since the last ice age occurred. The era of warmer temperatures became known as the medieval warm period and the subsequent cold period the Little Ice Age, LIA. However, the view that the MWP was a global event was challenged by other researchers. The IPCC First Assessment Report of 1990 discussed the medieval warm period around 1000 AD, which may not have been global, and the Little Ice Age, which ended only in the middle to late 19th century. It stated that temperatures in the late 10th to early 13th centuries, about AD 950 to 1250, appear to have been exceptionally warm in Western Europe, Iceland, and Greenland. The IPCC Third Assessment Report from 2001 summarized newer research. Evidence does not support globally synchronous periods of anomalous cold or warmth over this time frame, and the conventional terms of Little Ice Age and medieval warm period are chiefly documented in describing Northern Hemisphere trends in hemispheric or global mean temperature changes in past centuries. Global temperature records taken from ice cores, tree rings, and lake deposits have shown that the Earth may have been slightly cooler globally, by 0.03 degrees Celsius, than in the early and the mid-20th century. Paleoclimatologists developing region-specific climate reconstructions of past centuries conventionally label their coldest interval as LIA and their warmest interval as the MWP. Others follow the convention, and when a significant climate event is found in the LIA or MWP timeframes, they associate their events to the period. Some MWP events are thus wet events or cold events, rather than strictly warm events, particularly in central Antarctica, where climate patterns that are opposite to those of the North Atlantic have been noticed. Global climate during the medieval warm period. The nature and extent of the MWP has been marked by long-standing controversy over whether it was a global or regional event. In 2019, by using an extended proxy dataset, the PAGES 2K consortium confirmed that the medieval climate anomaly was not a globally synchronous event. The warmest 51-year period within the MWP did not occur at the same time in different regions. They argue for a regional instead of global framing of climate variability in the pre-industrial Common Era to aid in understanding.
North Atlantic.
Greenland ice sheet temperatures interpreted with 18O isotope from 6 ice cores, Vinter, B. et al., 2009.
The data set ranges from 9690 BC to AD 1970 and has a resolution of around 20 years.
That means that each data point represents the average temperature of the surrounding 20 years. Lloyd D. Keigwin's 1996 study of radiocarbon-dated box-core data from marine sediments in the Sargasso Sea found that its sea surface temperature was approximately 1 degrees Celsius 1.8 degrees Fahrenheit cooler approximately 400 years ago, during the LIA, and 1,700 years ago and was approximately 1 degree Celsius warmer 1,000 years ago,
during the MWP.
Using sediment samples from Puerto Rico, the Gulf Coast, and the Atlantic coast from Florida to New England, Mann et al., 2009, found consistent evidence of a peak in North Atlantic tropical cyclone activity during the MWP, which was followed by a subsequent lull in activity.
Iceland.
Iceland was first settled between about 865 and 930, during a time believed to be warm enough for sailing and farming. By retrieval and isotope analysis of marine cores and from examination of mollusk growth patterns from Iceland, Patterson et al. Reconstructed a stable oxygen, delta 180, and carbon, delta 13C, isotope record at a decadal resolution from the Roman warm period to the MWP and the LIA. Patterson et al. Conclude that the summer temperature stayed high but winter temperature
decreased after the initial settlement of Iceland. Greenland.
The last written records of the Norse Greenlanders are from an Icelandic marriage in 1408 but were recorded later in Iceland, at Vulsey Church, which is now the best preserved of the Norse ruins. The 2009 Mann et al. Study found warmth exceeding 1961 to 1990 levels in southern Greenland and parts of North America during the MWP, which the study defines as from 950 to 1250, with warmth in some regions exceeding temperatures of the 1990 to 2010 period. Much of the northern hemisphere showed a significant cooling during the LIA, which the study defines as from 1400 to 1700, but Labrador and isolated parts of the United States appeared to be approximately as warm as during the 1961 to 1990 period. Greenlandic winter oxygen isotope data from the MWP display a strong correlation with the North Atlantic Oscillation, NAO. 1690 copy of the 1570 Skalholt map, based on documentary information about earlier Norse sites in America. The Norse colonization of the Americas has been associated with warmer periods. The common theory is that Norsemen took advantage of ice-free seas to colonize areas in Greenland and other outlying lands of the far north. However, a study from Columbia University suggests that Greenland was not colonized in warmer weather,
but the warming effect in fact lasted for only very briefly. c. 1000 AD, the climate was sufficiently warm for the Vikings to journey to Newfoundland and to
establish a short-lived outpost there.
Lance aux Meadows, Newfoundland, today, with a reconstruction of a Viking settlement.
In around 985, Vikings founded the eastern and western settlements, both near the southern tip of Greenland. In the colony's early stages, they kept cattle, sheep, and goats, with around a quarter of their diet from seafood. After the climate became colder and stormier around 1250, their diet steadily shifted towards ocean sources. By around 1300, seal hunting provided over 3/4 of their food. By 1350, there was reduced demand for their exports, and trade with Europe fell away. The last document from the settlements dates from 1412, and over the following decades, the remaining Europeans left in what seems to have been a gradual withdrawal, which was caused mainly by economic factors such as increased availability of farms in Scandinavian countries.
Europe. Substantial glacial retreat in southern Europe was experienced during the MWP.
While several smaller glaciers experienced complete deglaciation, larger glaciers in the region survived and now provide insight into the region's climate history. In addition to warming-induced glacial melt, sedimentary records reveal a period of increased flooding, coinciding with the MWP, in Eastern Europe that is attributed to enhanced precipitation from a positive phase NAO. Other impacts of climate change can be less apparent, such as a changing landscape.
Preceding the MWP, a coastal region in western Sardinia was abandoned by the Romans. The coastal area was able to substantially expand into the lagoon without the influence of human populations and a high stand during the MWP. When human populations returned to the region, they encountered a land altered by climate change and had to re-establish ports. Other regions. North America.
In Chesapeake Bay, now in Maryland and Virginia, United States, researchers found large temperature excursions, changes from the mean temperature of that time, during the MWP, about 950 to 1250, and the Little Ice Age, about 1400 to 1700, with cold periods persisting into the early 20th century. which are possibly related to changes in the strength of North Atlantic thermohaline circulation. Sediments in Piermont Marsh of the lower Hudson Valley show a dry MWP from 800 to 1300. In the Hammock River Marsh in Connecticut, salt marshes extended 15 kilometers farther westward than they do in the present due to higher sea levels. Prolonged droughts affected many parts of what is now the western United States, especially eastern California and the west of Great Basin. Alaska experienced three intervals of comparable warmth, 1 to 300, 850 to 1200, and since 1800. Knowledge of the MWP in North America has been useful in dating occupancy periods of certain Native American habitation sites, especially in arid parts of the western United States. Aridity was more prevalent in the southeastern United States during the MWP than the following LIA, but only slightly. This difference may be statistically insignificant. Droughts in the MWP may have impacted Native American settlements also in the eastern United States, such as at Cahokia. Review of more recent archaeological research shows that as the search for signs of unusual cultural changes has broadened, some of the early patterns, such as violence and health problems, have been found to be more complicated and regionally varied than had been previously thought. Other patterns, such as settlement disruption, deterioration of long-distance trade, and population movements, have been further corroborated.
Africa.
The climate in equatorial eastern Africa has alternated between being drier than today and relatively wet. The climate was drier during the MWP, 1000 to 1270. Off the coast of Africa, isotopic analysis of bones from the Canary Islands inhabitants during the MWP to LIA transition reveal the region experienced a 5 degrees Celsius decrease in air temperature. Over this period, the diet of inhabitants did not appreciably change, which suggests they were remarkably resilient to climate change.
Antarctica.
The onset of the MWP in the Southern Ocean lagged the MWP's onset in the North Atlantic by approximately 150 years. A sediment core from the eastern Bransfield Basin, in the Antarctic Peninsula, preserves climatic events from both the LIA and the MWP. The authors noted, the late Holocene records clearly identify neoglacial events of the LIA and medieval warm period, MWP. Some Antarctic regions were atypically cold, but others were atypically warm between 1000 and 1200.
Pacific Ocean.
Corals in the tropical Pacific Ocean suggest that relatively cool and dry conditions may have persisted early in the millennium, which is consistent with a La Nina-like configuration of the El Niño Southern Oscillation patterns. In 2013, a study from 3 U.S. universities was published in Science magazine and showed that the water temperature in the Pacific Ocean was 0.9 degrees warmer during the MWP than during the LIA and 0.65 degrees warmer than the decades before the study.
South America.
The MWP has been noted in Chile in a 1,500-year lake bed sediment core, as well as in the eastern Cordillera of Ecuador. A reconstruction, based on ice cores, found that the MWP could be distinguished in tropical South America from about 1050 to 1300 and was followed in the 15th century by the LIA. Peak temperatures did not rise as to the level of the late 20th century, which were unprecedented in the area during the study period of 1,600 years.
East Asia.
Gu et al. Studied temperatures in China for the past 2,000 years and found high uncertainty prior to the 16th century but good consistency over the last 500 years, highlighted by the two cold periods, 1620s, 1710s and 1800s, 1860s, and the 20th century warming. They also found that the warming from the 10th to the 14th centuries in some regions might be comparable in magnitude to the warming of the last few decades of the 20th century, which was unprecedented within the past 500 years. Generally, a warming period was identified in China, coinciding with the MWP, using multi-proxy data for temperature.
However, the warming was inconsistent across China.
Significant temperature change, from the MWP to LIA, was found for northeast and central East China but not for northwest China and the Tibetan Plateau. During the MWP, the East Asian Summer Monsoon, ASM, was the strongest it has been in the past millennium, and was highly sensitive to the El Niño Southern Oscillation, ENSO.
The
Muas Desert witnessed increased moisture in the MWP. Peat cores from peatland in southeast China suggest changes in the EASM and ENSO are responsible for increased precipitation in the region during the MWP. However, other sites in southern China show aridification and not humidification during the MWP, showing that the MWP's influence was highly spatially heterogeneous. Modeling evidence suggests that EASM strength during the MWP was low in early summer but very high during late summer. In far eastern Russia, continental regions experienced severe floods during the MWP while nearby islands experienced less precipitation, leading to a decrease in peatland. Pollen data from this region indicates an expansion of warm climate vegetation with an increasing number of broadleaf and decreasing number of coniferous forests. Adhikari and Kumin, 2001, investigating sediments in Lake Nakatsuna, in central Japan, found a warm period from 900 to 1200 that corresponded to the MWP in 3 cool phases, 2 of which could be related to the LA. Other research in northeastern Japan showed that there was 1 warm and humid interval, from 750 to 1200, and 2 cold and dry intervals, from 1 to 750 and from 1200 to now.
South Asia.
The Indian summer monsoon, ISM, was also enhanced during the MWP with a temperature-driven change to the Atlantic multi-decadal oscillation, AMO, bringing more precipitation to India. Vegetation records in Lahaul and Himachal Pradesh confirm a warm and humid MWP from 1158 to 647 BP. Pollen from Madhya Pradesh dated to the MWP provides further direct evidence for increased monsoonal precipitation. Multi-proxy records from Pukkot Lake in Kerala also reflect the warmth of the
MWP. Middle East.
Sea surface temperatures in the Arabian Sea increased during the MWP, owing to a strong monsoon. During the MWP, the Arabian Sea exhibited heightened biological productivity. The Arabian Peninsula, already extremely arid in the present day, was even drier during the MWP. Prolonged drought was a mainstay of the Arabian climate until around 660 BP, when this hyperarid interval was terminated.
Oceania.
There is an extreme scarcity of data from Australia for both the MWP and the LIA. However, evidence from wave-built shingle terraces for a permanently full lake air during the 9th and the 10th centuries is consistent with a La Nina-like configuration, but the data are insufficient to show how lake levels varied from year to year or what climatic conditions elsewhere in Australia were like. A 1979 study from the University of Waikato found temperatures derived from an 18:0/16:0 profile through a stalagmite found in a New Zealand cave, 40.67 degrees south, 172.43 degrees east, suggested the medieval warm period to have occurred between AD c. 1050 and c. 1400 and to have been 0.75 degrees Celsius warmer than the current warm period.
More evidence in New Zealand is from an 1,100-year tree ring record,